let's look at how to use the graphing calculator to do transformations. Now, I've got the TI-84 plus CE, but again, this is going to be very similar with other Texas Instrument calculators. Now, I'm going to go ahead and start with the square graph. So let's go ahead and go to y equals, and let's hit x squared. Now, as we remember, that x squared graph looks vaguely like the letter U. Technically, it's called a parabola. And let's do some transformations to that. So what happens if I do x squared plus 3? Well, let's come here to y equals, and let's add a plus 3 on at the end. So that plus 3 is going to move me up 3 units. We were at 0, now we've moved up 3. We can compare them if we'd like with the graphing calculator. Anytime we want to compare, I could have the base graph and then have the second graph as well. So my base graph now is in blue, and my new graph is there in red, and you can see I've moved it up 3. Let's try another one. Let's try x plus 2 quantity squared. Let's come in. I'm going to keep my base graph there, but let's do it here. I always tell students, if you need parentheses to write it out by hand, you need to have it in parentheses on the calculator as well. So in parentheses, x plus 2, and then there's my quantity squared, and let's see what it looks like. Now again, I've still got my base graph there in blue, so I can see how I've moved it, and now I've got my red graph. So here, I went left 2. If I add or subtract on the outside, I'll go up and down. However, if I add or subtract on the inside, that is left or right. And as you can see, this is backwards from how I expect it to be. Normally a plus, I would go to the right, but I am going to go to the left. Now I have students that sometimes don't really believe that. Well, you can always get some numbers if you're not quite sure how it works, and the graphing calculator can help you with that. So if I hit second graph for my table, I get a list of values there. Let's hit some of those easy ones. So for example, x is -1, and then plus 2, that's +1, squared is 1. 0, I'll just have a 2 in there, squared it to get 4. Again, those y values, I'm looking at the red list because that's this graph. So you can always get a couple of values up there as well if you don't believe it or if you just want to check it. Let's hop back here. We've seen left and right. Let's do a stretch. So let's do y equals 4 times x squared. So 4x squared. Don't need parentheses because I didn't need it by hand. This is a stretch. Now, I always tell students the stretches and shrinks are hard to tell, especially if you don't have that base graph. So here I have stretched it by 4, and hopefully now that you can see both the blue and the red graph, we can see that that red graph is skinny. So it looks like I've took that and kind of pulled it vertically. And similarly, if I wanted to shrink, let's try 1/3 x squared. Now I always put parentheses around my fractions. So as I type that in, I'm going to type it in like that. And that's just to make sure that my calculator does not misinterpret this and, for example, accidentally think that that x squared is in the denominator, because that is a very different graph than the one I actually want to get. So there's my base graph. And this one is a shrink. Again, we're going vertically, so I'm thinking of taking this and squishing it down this direction. That red graph now looks like it's fatter. And again, that 4 or 1/3 just tells me by how much am I stretching it or shrinking it. Last but not least, let's look at reflections. So let's try y equals -x squared. As always, make sure to think, am I actually subtracting or is it a negative? It's a negative, so I'm going to go ahead and use my negative key way down here at the bottom. And let's see what that looks like. There's my base. Here's my new one. If that negative is out in front, that is an x-axis reflection. However, if we have the negative on the inside, as we hopefully remember, that is a y-axis reflection. And what happens if I do that for this particular one? Let's come back in here. Again, I need it parentheses here, so I'm going to also need parentheses on my graphing calculator. And let's hit graph. There's my blue base graph. And that red graph is exactly over it. Well, if I take this graph, I'm going to try to make that picture of my ends and flip it like that, well, yeah, it looks exactly the same. And that's because if I take a negative and square it, well, that's positive. For this graph, I can't actually see that y-axis. So let's actually try a different graph. Let's try the square root graph, and then let's actually graph two graphs off that. Let's graph negative out on the side, and then let's put a negative on the inside as well. So let's come in here and clear out my old graphs. So let's do as our new base graph, the square root of x. Again, square root, I hit second that square. So I said first, let's put a negative on the outside. And then for my second one, let's put a negative on the inside. Well, we said that one should be an x-axis because it's on the outside. This one should be a y-axis because it's on the inside. Let's see what it looks like. Let's hit graph. So here's my base graph here in blue. My red graph, that does look like an x-axis reflection. And now this red one, or black one, I'm sorry, over here on the left is my y-axis. And now I can hopefully see that y-axis reflection a little bit more easily. I always tell students, no matter how complicated these transformations are, as long as I type it correctly into my calculator will do it correctly. So let's say I have a pretty complicated one. Let's do negative 1/2, and let's do, how about x plus 4? Let's do the cube graph just for a change of pace, and then minus 5. All right, so let's come to y equals. Let's clear out all of my old graphs. Now again, I always put that fraction in parentheses. You usually don't need it. The calculators are pretty good about interpreting that correctly these days, but that's just something I like to do. And again, that is a negative sign, not a subtraction sign out front. And then in parentheses, x plus 4. To do the exponent, I'm going to hit this little caret key. So I hit caret to put the 3, and I'm still up in that exponent position. So let's hit right to get out of there. And then that is subtraction, so make sure I hit my subtract 5. Again, this is a place I have to be careful. If I accidentally put a negative sign here, or a subtraction sign here, the subtraction sign would give me an error, because my calculator is trying to figure out what I'm subtracting it from. Whereas here, it would work, but it would be a very different graph. So in particular, watch for those negatives and subtractions. Again, I try to think of it as negative or subtraction, rather than that more confusing term minus, to make sure I'm hitting the correct button. Now let's go ahead and hit graph. You'll notice I typed it in as y2. That's okay, my graph will still do it. It's just going to get it in red instead of blue. And for this one, as we can hopefully see, that minus 5, I went down 5, which it's on the outside. Expect that to be vertical. The plus 4 was on the inside, and those are backwards from how I thought it should be. So I did go left 4. That 1/2 in front is going to shrink, and specifically by half. And that negative sign is way out in front, so that is an x-axis reflection. And again, if you do want that basic graph to kind of compare with, I can come in here and type that x cubed graph up there as well, just so I can compare and contrast the two of them. So again, that blue graph is the basic one, and that red graph is all of the things that I did to change it. So again, always be careful, double check how you've typed it in. Again, if I type the graph in wrong, my calculator is going to give me the wrong picture.